In this video, we will understand the objectives of control in power system and the different reliable operations of power system. So I am Professor Mohan, working as assistant professor in Department of EEE, SJBIT. So we can classify the different objectives of control into three subparameters. Requirements of power system has been identified with four objectives, and the requirements have been achieved. So how are they achieved? What all are required to achieve the requirements of power system and what they should maintain? So the three parameters will be remembered with respect to what they should be maintained, the four parameters with respect to what are the requirements of the power system and how they are achieved. The fundamental requirements of power system with respect of the size, there are four parameters here. Let's see one by one. One is with respect to the changing load demand for active and reactive power. As we are all aware, the active power is what we consume, what we can feel. The reactive power is the work done to achieve your active. So the system should generate only active power with some minimum quantity of reactive, and the reactive power has to be supplied by some local operations. So as we are aware that the amount of power or current increases if the reactive power increases, thus putting some more pressure on the grid. So electricity cannot be conventionally stored in sufficient quantities. Therefore, adequate spinning reserves of active and reactive power should be maintained to take care of sudden variations in the load demand. So one requirement is the system should meet continuous changing active and reactive, and to satisfy that we should have sufficient spinning reserves. The power quality should meet certain standards with respect to frequency, amplitude, waveform of the generated voltage, and the level of reliability. So frequency, as we are aware, is this 50 Hz, and the variation should be 49.5 to 50.5. The amplitude of voltage has a tolerance of 5% or 5 to 10% at each bus voltages, either three phase or single phase. The last one, the system should supply energy at the minimum cost. So these are the four requirements of power system, and the next heading will see how are these maintained. Now to achieve the above objectives, we have several levels of controls that are integrated. So to achieve 1 and 2, so we give sufficient excitation control for generation to satisfy the changing loads of active and reactive power. Automatic generation control is responsible for maintaining active power balance. The automatic generation control also maintains the scheduled power flows in tie lines, which are responsible for power transfer between different control areas. The third point, maintaining the standards, are achieved by distribution level control such as capacitor, wave shaping circuits. These devices maintain a system voltage at correct frequency and amplitude, and also helps in injecting or removing the hormones to the load. So to remove the harmonics, in fact, we inject it in a reverse direction so that they can actually cancel each other. The third point again, the transmission controls. What are those? The control devices are tap tuning transformers, fact devices used to control your reactive power flow, shunt reactors, shunt capacitors, phase shifting transformers, and HVDC controls. All these are with respect to controlling your reactive power. The last point, the operation and control of systems should ultimately meet the following. So these are the three parameters which they should meet. One is stability, security, and reliability. Continued intact operation of the system following a disturbance is called as stability. Security, that is the degree of risk in the power system ability to survive contingencies without interruption of the customers. Reliable, it is the probability of satisfactory operation over a long period. Now let us see the key concept of reliable operations. So North American Electric Reliability Corporation has proposed 7 key concepts. So what are these seven key concepts? We'll understand them through an acronym. So these 7, let us see one by one. So BGL here stands for balance between generation and load. RP&D, the second term with respect to key concept, that is balance reactive power generation and demand. TL stands for setting thermal limits. S stands for system stability. N-1 stands for satisfying N-1 reliable conditions. O stands for operator reliability. And PE stands for planning for different emergency conditions. So let's take up them one by one. So balancing the generation and load. The load on the power system is dynamic, as we are aware, and changing at all time. It's not constant. Although we have, let us say, we have a situation where all have same equipments, but still their operations are not balanced. So each one at their own time, they switch on and switch off their appliances. The production by the generation must be scheduled to meet this continuously changing load. The automatic generation controls are used to match the generation with demand. O frequency and under frequency relays operate when the frequency deviation across the present set values. Next, as we saw, it is reactive power generation and demand balance between these two. So as we saw in the earlier slides, the reactive power controls are actually met by fact devices, HVDC control systems, phase shifting transformers, shunt capacitors, right? So reactive power sources are generators and capacitor banks. So the generator automatic voltage regulator controls the voltage level of generator. Fax controls are commonly used for reactive power control. Ensuring thermal limits are not exceeded, maintaining system stability. The heating limits of the overhead lines must not exceed, which will lead to sagging of lines, leading to short circuit, rate tripping, and ultimately grid collapses. So the thermal limit exceeds, as we have seen in earlier classes, about what are the consequences has to be placed because of sagging, and because of sagging, the capacitance between the line and the ground also increases, and its problems in power system. So maintaining system stability. Power system stability is the ability of an electrical power system for given initial operating conditions to regain a state of operating equilibrium after being subjected to a physical disturbance. The stability limits will specify the maximum power, that's 1.5 times of your Pmax, that can be transferred over line. The angle stability, that is to maintain the generation in synchronism. The ability of the generator connected to the grid to remain in synchronism. Voltage stability, that is 5 to 10% of tolerance of your bus voltage. Is the ability of the system to maintain steady acceptable voltage at all buses in the system under normal operating conditions and also during disturbance. N-1 meeting N-1 reliable conditions. This means that the system should remain operation and secure even after the loss of largest generator in the system. Further, after contingency, the operators must assess the health of the system so that it is suitable for another contingencies. So planning, design and maintenance of operator reliability. The planning, design and maintenance should be such that the system should be operated reliably and within safe limits at all the time. So you should have two types of planning, one is short term and long term. The last one, prepare for emergencies. In spite of all the plans that we have done, good design, and all weather because of weather fluctuation, operator error, failure of software or the equipment, etc. So there might be some emergencies which one has to be planned and prepared for. So the operator must be trained to prepare for such emergency situations. So thank you for watching the video. Please do subscribe our channel to enhance your knowledge.